welcome to the second episode of Better Living with Physics. And in this class, we are going to recap of what we did in the last class, and of course, we are going to venture further and we are going to learn about balance, imbalance, and motion. But before that, let me just talk about what we did in the last episode. We kind of checked out that some couple of memes, and we realized that every meme is not rated equally by everyone. So it's hard to arrive at a consensus where you all agree that a given rating to a meme is a real rating or is the correct one, because that's perspective. Everyone can talk about a meme or understand a meme in a different level, and that led us to conclude that not everything in the world is measurable, and that led us to define what is measurement and what is a physical quantity. Once we found that a physical quantity, as you will see in this screen here, that there is physical quantity and it should have a number and a unit, of course, but what is if it does have a direction, it will be called a vector physical quantity, as you can see here. So far so good. Now let's talk about the second story. That's what I'm interested in discovering with you today. So the second story is about balance, imbalance, and motion. And as you can see here, that there is a bit of motion in everything we want to study. Why is that a valid statement? Because even if you think about the word emotion, if you think about the word emotion, it does have motion in it, right? So it's actually called flow of thoughts, or moving thoughts create emotion. And when do we have thoughts floating in our mind? Maybe when one part of the mind is disagreeing with other part of the mind, then the thought starts to flow, and that creates emotion. So indeed, everything is in motion. And Blaise Pascal, a very famous scientist, once said that life exists in motion, and complete stillness is death, or complete rest is death. So we have certain Greek philosophers backing this thing up, but well, if you think about people who try to study these emotional quantities or these emotions, that's basically movement of thoughts. They are called psychologists. We have seen that in the previous episode. Let's dive a little bit deep into what kind of motions we can generalize in daily life. So we can have something called transportation, that is bulk movement of matter, whereas transformation will be more like the next picture is gonna explain my point about transformation. So check this out. If you look at this small Hulk growing into a bigger Hulk, that's like transformation, but not really. Transformation could be a physical or chemical change as well. So transformation can be thought about chemistry, that is dealing with motion, okay? So that is like physical or chemical change. Whereas broadly you can say that, okay, the growth is also a kind of motion. Aging with time, like hair turning gray, skin having wrinkles, these aging and growth process is also a kind of motion. Although not all motions are reversible, certain motions happen once. Like if you age once, you can't have go back and be young and again age. So certain motions are irreversible, and life is full of examples of irreversible motions. So what do we conclude from this? That what is actually motion? So in physics, we will be mostly dealing with transportation, and to define only transportation, this kind of definition can be used about the motion. So is something changing its position? So this is a new color here, position with time when compared to reference to a point / frame. So if something is changing its position, not still, then it's said to be moving. But how do we define position? We cannot define position on its own. We need a reference point to define position, and that is why there is a little bit of color difference for the word reference here. And then to define motion itself, we have to use a new word here. Check this out. This new word here is used to define motion, and it's indeed very interesting. It's called time. In fact, how motion and time are related, they are very, like, they cannot be separated. In fact, how we measure motion is, how we measure time is using motion. We have periodic motions. So let's that brings us to the next part of the quest here, that how we can make sense of this definition of motion. Changing position, then we are using the word time, and then right now we don't know how to measure time. We are not advanced enough, let's say. So how did people started observing time? So one thing, as I said, is that time can be measured using something that is a repetitive motion, like from day to night and night to day. So this one repetition is called 124 hours. From a full moon to a no moon to again a full moon, again a repetitive natural motion is traditionally used to define one month, and maybe from one season to the next and next, and the same season again is 1 year. So basically, the periodic motions have been used all throughout the history to measure time, but with the advent of man-made periodic motion, in fact, like pendulum, that is when we started using man-made periodic motions to measure time. And that is why when I said that motion and time are inseparable, that is why I said, because the basic device we use to measure time is in fact a periodic motion. And if you have been with me in the first episode, we checked out the definition of time. It was with respect to the atom of cesium transitioning from high excited state to a normal state. So this is about how the time and periodic motion help us define time. So that brings us to the next part, that okay, what causes motion? How we can make something move or something change its position? So if you check this diagram out, there is a table lying flat and there is a droplet of water, and there is water flowing through the edge of the thing when the table is tilted. Well, the table is tilted, causing some imbalance and causing some motion. What is that imbalance called? That imbalance is called net force. Like some residual force or some net force is acting on this fluid or this drop that has made it fall down the table. So we just had this simple observation of a droplet of water on a table, and that lets us figure out that some imbalance of height of the table or the surface leads to motion. So we are expanding this experiment in a broader sense to look at what causes motion. So right now I'm going to make a very bold statement, and I'll prove myself through in the next couple of minutes through this statement, or try to prove my statement correct. So the statement is, it is safe to say that any motion is a result of imbalance. We just looked at the table example and a droplet of water. The height flat, the table not being flat led the water to drop. So it's safe to say that imbalance will cause an motion. In fact, I'm making another bold statement, that the rate of motion depends on the amount of imbalance. Well, I'm going to defend these statements in using a couple of examples, but and this is going to be called the blueprint of not blueprint, actually some examples of motion and the imbalances. So I'm going to zoom it in a way that actually all of you can see this bit. So check this out. The first imbalance I'm going to talk about is motion of a solid object in bulk. And what causes this imbalance? We have already checked this out. It's caused by an unbalanced force. A net force acting on a point on an object will make it move. So that's transportation. Alright, so what is the next kind of motion I'm trying to prove the statement using this example again? Wind. Wind is motion of air particles. So what is the imbalance causing the wind to flow? Pressure imbalance between 2 points will cause the wind to flow. So you can check this out here, and another example of motion I can take is diffusion. So motion of solute particles in a given volume. So how does diffusion happen? There is a concentration difference between A point and B point, and that is what leads the particle from higher concentration to lower concentration move, and that is diffusion. So we have seen a couple, it's kind of valid till now, that there is an imbalance required. So for the heat energy to flow, or the transfer of heat energy, what is the imbalance required? Temperature, you already know it. So we can have more examples. Like I can say that, okay, if there is a potential imbalance in a conductor, that leads for the current to flow. So that again leads to, like, motion of charge is through potential imbalance. Although I have not mentioned it here, so you can have like a table that is having not just these four members, but you can add few more examples of motion from your daily life, and you can make your own table of this kind and look at what causes that kind of motion. If the temperature difference is large, then heat flow will be faster. If the force applied, net force acting on an object is more, then it will move faster. So even the second statement when I made, I was bold but I was correct, I think, that if we look into these two statements again, we can very safely say that yeah, they hold true for various examples we have taken, and this in fact is gonna be our guiding point from now on. Whenever we want to study about motion, we will try to know what kind of imbalance causes that motion, and we will try to measure this imbalance. So we will kind of measure this imbalance that causes this we will try to create the imbalance. If we want faster motion, we want to measure the motion, we will try to measure the imbalance so that we can relate it to the amount of motion created. So that is gonna be our quest in the rest of the chapters in physics. We'll always take an example of motion, we'll look at the imbalance causing motion, and we'll mathematically try to model those kind of imbalances. Alright, so let me check if there is more planned for this class today, otherwise we can call it a day. I don't think we have more planned for this day. That's awesome. See you guys in the next episode.